distribution. In the previous video, we talked about normal distribution, which is for continuous data sets. So in this video, we're going to be talking about binomial distribution. Now, binomial distribution describes outcome when there are only two possible outcomes. When there are only two possible outcomes. For example, when you have success or failure, yes or no, alive or dead, positive or negative. When you're throwing a coin, you have two possible outcomes, heads or tail. So we use binomial distribution for that. Now, the conditions for binomial distribution, it's used when there are only two outcomes. We've explained that already. When the trials are independent, when probability stays constant, when the number of trials is fixed. So these are the conditions where we use binomial distribution. Now, an example of this in a clinical scenario is when we have a vaccine trial, right? Where we have that there are two possible outcomes in this scenario. It's either you're protected or you're not protected in a vaccine trial. So if we have 100 people receive a vaccine, the number who develop immunity follows a binomial distribution. Why? Because there are only two possible outcomes, which is protected or not protected. So this is going to follow a binomial distribution. Now, we move into the calculation of it. Using still a clinical scenario, a new antibiotic cures an infection in 80% of the patients. A nurse administers the drug to 5 patients. What is the probability that exactly 4 patients recover? All right, 80% patients, the nurse administers to 5 patients. What is the probability that exactly 4 patients recovers? Now, we're going to use this funky looking formula and we're going to try to break down what each of them means. Now, the N here means the number of trial. That means the number of times we tested it. So in this case, the nurse administers to 5 patients. So our number of trials is N, right? Now, K is the desired success, which is usually in the question. So we desire, what they are asking us about is for the 4 patients. So K here is the desired successes, which is 4 recoveries. Now, what is P? P here is given as percent, 80%, but we do not use the percent, we use the decimal, right? So the probability of success in decimal is here is 80%, but we change 80% to decimal. It's going to give you 0.8. Now, this 1 minus P, in most times it's called Q. 1 minus P is the probability of failure, right? And the probability of failure is 1 minus the probability of success. That's basic probability, right? That the probability of failure is 1 minus the probability of success. So 1 minus 0.8 gives you 0.2, right? So N, which is the number of trial, out of K, which is the desired success, with P, which is the probability of the success, raised to the power of K, which is the number of desired successes, then 1 minus P, right, the probability of failure, and then N minus, that's the number of trials minus the number of desired successes. Honestly, you have to look at this formula. I'm sure you have to look at this formula again and again and try to use it to solve different questions to get acquainted with it, because you're not just going to look at it at one time and just get it. So we try to solve this question. Remember 5, what is 5 again? 5 is the number of trials, right? This is the number of trials out of 4. What is 4? 4 is the desired success, which is what they asked us in the question. 0.8 is what? 0.8 is the probability of success, which is 0.8, which we were given in the question as 80%. We changed it to decimal. Then raised to the power of 4. How did we get this 4? What is 4? 4 is k. What is k? The number of desired success, which is 4. Then 0.2. Remember, 0.2 is 1 minus the number of the probability of success, right? 1 minus 0.8 to give you 0.2. Then raised to the power of 1. How did we get 1? N minus k gave us this 1. So 5 minus 4 will give us 1. So we break each of them down, starting with this 5 out of 4. Now, really, it's going to be a combination. I don't know if you still remember combination in high school, but I tried to break it down here on the right side, what really goes on here. 5 combination 4 is going to give you 5. Now, how did we get this? It's going to be 5 factorial all over 4 factorial into 5 minus 4 factorial. That sounds kind of funky, but we'll break it down. 5 factorial is 5 times 4 times 3 times 2 times 1. Simple as that. 4 factorial is 4 times 3 times 2 times 1. 5 minus 4 is 1. 1 factorial is 1. So putting everything together, we say that 5 combination 4 is 5 times 4 times 3 times 2 times 1. Then 4 times 3 times 2 times 1. When you do this math, you're going to get 5. That's why 5 combination 4 is 5. Now, 0.8 raised to the power of 4. This, you can use your calculator for this. You get 0.4096. 0.2 raised to the power of 1 is going to give you 0.2. Now, putting everything together, 5 times 0.4096 times 0.2 will give you 0.4096. So that's the probability that 4 people will recover. That's the probability that 4 people will recover. If you want to change it to percentage, we can say that 40%, or let's say 41, because when you approximate this, 41% of the patient will recover. So that is how we use this formula. You can rewatch this video and try to use it in other questions to really get a grasp of the calculation part of this. But the major context, the basic concept of binomial distribution is its use when there are 2 possible results: success, failure, yes or no, alive or dead, positive or negative, heads or tails. So that's it about binomial distribution.